Ecosystem in the sense, in Hadoop, the main ecosystem what we have is, just a second. The other ecosystem components are available. Those ecosystem components are HDFS. What is this HDFS? You are going to get the data from heterogeneous sources, right? When we get the data from heterogeneous sources, like I may get the data from cloud, I may get the data from mainframe system, I may get the data from some traditional database systems like Oracle, Teradata, those kind of systems. When we got the data, to where we are storing the data inside Hadoop, the place where we are going to store the data inside Hadoop is one we simply going to call as a HDFS. The full form of HDFS is Hadoop Distributed File System. Hadoop Distributed File System is a one which is going to store the data across the cluster in a format of blocks. Every file, I am storing some 10 GB file, for example. When I am storing some 10 GB file, the 10 GB file is going to split into multiple blocks. It's going to store that file into the HDFS. Let me show you the diagram, how it will be there. Means, see, this is the way. This is the actual diagram for storing a file. This particular file, whatever we are specifying there, this file I want to divide into a number of blocks. He is simply going to call in Hadoop terminology, they are all nothing but blocks. Okay, these blocks, whatever we are having, these blocks are going to be split into, this file is going to be split into multiple blocks. Those are going to store across this cluster. See here, this is the way we are going to store our data. And even though one machine is down at any point of time, this is the machine which is down at any point of time, for example. When this machine is down here, that machine, whenever we have a failure, for example, then there is no loss of data. Why? And how that is achieved? That was achieved using a concept called replication. We will discuss what is this replication, how to store the data, what kind of replication we are going to achieve, what is the Hadoop HDFS architecture, and what is the name node, its functionality, what is data node, what is secondary name node, job tracker, task tracker. These are all the components we are going to discuss in Hadoop. And how to do Hadoop archive. There is a big advantage is there in Hadoop when we compare with the traditional databases or data warehouses. As I also worked on data warehouses earlier, in data warehouse systems, after files processed into data warehouse database, what are the files we are having? If you want to archive those files, we separately need some external tapes to archive the data, right? But here in Hadoop, we have online archives are there. An automatic archive mechanism is going to execute once the files are processed. That concept we will discuss. What is this rack awareness, balancer, health checkup? Sometimes my cluster may be down. How to check health status? My cluster health checkup. For that we have few commands. And balancer means assume that one node is fully utilized, but one node is not yet utilized. Just an example, when I am storing my data across this cluster, assume that one machine is fully utilized. For example, see, this fourth machine is fully utilized, but this machine is having a lot of space free. In such a situations, how to do the balancing of the cluster? That's called auto balancing. That's also you should not do manually. For example, you manually check which machine is having high volume of data. I don't want to maintain this machine high volume of data. I want to move from this machine to other machine. No need to do any manual operations here. It's also going to be an automated process. Okay, these kind of automated process is also available there, that we simply going to call as a balancing. Say block scanning, balancer, trash. Trash means, for example, if you delete one mail from your inbox of your Gmail or something, right? Is it going to be permanently deleted? No. It will be deleted into your trash directory first. Then, if you want to delete permanently, you can delete. Similar to that, in Hadoop also, we have a trash. If I remove any file, let me just show you some example, okay? I just want to remove one file. The command we can use for removing the file is Hadoop space dfs-rm space. I just want to give the path of one file. For the path, I'm just checking. This is the web UI. Web UI means we can see these files with the web UI. In the web UI, just going for the one file path. For example, I want to remove this file. Okay, I'm just opening this file. This is the file data, and I also stored here some video file. See this? This is the every day after class completion. Generally, I'm going to send class recordings to my attendees. When I'm sending the class recording, I'm just uploading, for example, in my Hadoop. This is the class recording. If you want to delete this one, or if you want to delete this file, for example, just I want to delete that file. Okay, I'm pasting that path of file. Press. When you delete this file, generally, if you are using any of Linux or this environment, it will automatically be deleted. But here, see this. Deleting in a sense is just moving the file. It's not permanently deleting or something. It's just moving that file to our Hadoop environment. I mean, from one place to other place. That's simply a call as it is just moving a file from our local machine to trash directory. See here, this is my local machine path and this is the trash path. It's just moving into trash path. It's not permanently moving. If you want to completely clear the trash, we have a command. One more command is there, Hadoop space dfs space -expunge. This is the command to completely empty the trash. See here, trash deleted, and it's going to create some checkpoint also, like emptying a trash, right, in our Gmails. Similar way. So like this, we are going to use some commands to open the file, to display the content of a file, to update the file. Instead of using commands also, we have even web UI. This web UI is the place where we can see the files data. See, these are all files. There are different files I copied. Okay, I want to see user data, for example. Any file, that may be CSV file, or that may be .test file. Any format file it will going to support in Hadoop. Or you may have, for example, some log file. See, this is the log. It does not require any structured or unstructured anything. Any type of file we can process. That we will discuss in HDFS. How to process the multiple different files. How to check the health checkup of this one, and commands on live environment, track awareness, black scanner, balancer, trash, health checkup. All we will have that one. Okay, how to do the archives and everything also we will discuss. Next we have a MapReduce. What is this MapReduce actually? Once we store the data across this cluster, on this data I want to do some operations, right? If I want to do some operations, we are going to write some programs. In an entire Hadoop, only one place where we are going to write some programs is nothing but a MapReduce. We will write some programs here. Some MapReduce programs we will write. I'll show you how to write some MapReduce programs. Actually, to write the MapReduce programs, that MapReduce program we are going to write in Java or .NET, any of these, that we are going to call in Hadoop. Where we are going to write that MapReduce programs? I'm just showing you the desktop. I'm just going there. Here, when we install Hadoop, we are also going to call get Eclipse. Eclipse is the software where it's going to be IDE. That IDE we are going to have to write a programs here. We will write the programs in this Eclipse. Let's wait for it to start. In MapReduce, what we are going to discuss is what is a MapReduce, what is the data types of the MapReduce, what is the mapper, reducer, partitioning, shuffling, sorting, and writing of some MapReduce examples. At least 10 to 15 programs I will show you in class by executing those all the programs in class. How to write the MapReduce programs and what kind of APIs we are going to use when you are writing the programs. And MapReduce also in our process, only we are going to have a map and reduce functionality. Rest of all the part going to take care by that map is the one which we are going to do processing of the data operations. Okay, just let me show you some example program you can understand here clearly. I'm just showing you some programs. I'm just showing you some basic program. See, this kind of program we are going to write here. This kind of the programs we are going to write there. See here. This is a Java program. I'll explain each and every line when we are writing these programs, like what are the APIs we need to import and what kind of classes we are going to write, like word count main method and map class, reducer class. There are three things are going to be there inside the MapReduce program. One we are going to call as a map, second one is reducer, and third one is main method also. Apart from that, when you are writing any MapReduce programs, let me just show you. Just a second, please. See, we are going to have that MapReduce programs, and we are going to create a jar file that for that particular MapReduce program. That jar file we are going to call in. Let me open the slide for that. Just a second to show you how the MapReduce programs are going to execute. Just a second. Let me show you the flow of the MapReduce program. See, this is the flow of MapReduce program. Once you store the data inside our Hadoop, okay, this is the HDFS. This HDFS data we will take by using input format data, whatever we are having, and we will do multiple splits. We will perform multiple splits of the data. And when we perform multiple splits here, we are going to have multiple records here. Record readers are there. Whatever the record readers we are having there. The record readers means these are the built-in APIs actually. You don't need to write any program here. And map is a program which you are going to write manually. See, actually in this entire flow of MapReduce execution, where users are going to be involved, you are going to write a program only for map and reducer part. Rest of splitting, input format, record reading, partitioning, sorting, and output format, finally writing the data into again HDFS. This entire process is going to take care by our cluster. That means your entire MapReduce process is going to take care by default APIs only. Only map and reduce programs you are going to write inside the MapReduce process. Rest all are going to be a built-in APIs will be take care. That's what, okay, that's a easy, okay, for even the who are coming from non-programming background also. For example, I am not from the programming background, I am coming from the database side or some other environment, then we can see that, okay, these all things are going to execute in background, but inside this also, this entire MapReduce Pro also, you are going to write only map and reducer part of the program. To run your map and reducer program, we are going to write a driver program also. That's about the flow of MapReduce. We will discuss what is this MapReduce and how to write some programs, how to execute those programs and everything. Then we will go for pig. Who are coming from the ETL background, especially, they are using this pig actually. Because pig is going to have its own a scripting language. That's we are going to call it a pig Latin. Pig Latin is the one which is simply goes to, okay, pig is simply one which is going to have some own language called Pig Latin. That is going to be, we are also going to use. This is look like, for example, we have a Unix language, right? Unix scripts. Similar kind of scripts we are going to write in Pig also, but not that much Unix scripts also. Very simple language. That simple language we are going to write, okay, for executing of the Pig scripts. I'll show you how to write the Pig scripts and everything. This is very flexible and very user friendly for the ETL people. And next we will also go for Hive. Hive is a one which is going to, this particular Hive is a one which is going to be, just a second, I'm showing you the diagram. Hive is a kind of data warehouse within Hadoop. See, Pig is a scripting language And Hive is a one which is a SQL-like queries language. That means Hive is a data warehouse within Hadoop. From this particular database, whatever we are having, this particular tables, whatever we are creating in Hive, from that, okay, we are using some reporting tools. Those reporting tools, right, or we can contact directly to this Hive and we can get the data from these Hive tables. To pick that Hive, you can get the data from HDFS or HBase also. What is this HBase? HBase is a one which is going to have a NoSQL database. It can store the petabytes of data. Whatever the data we are getting from traditional database systems, those petabytes of data we are storing into HBase. We'll also discuss how to store the data in HBase without using SQL queries. By using simple commands, put, get, scan, those kind of commands we are going to use there. And next, we'll also go for the scoop and flow. Yes, I have my data in cloud. I have my data in weblog. I have my data in Twitter, Facebook. I want to get the data, those kind of data from those environments into my big data environment. There are two ecosystem components are there here. One is called scoop and second one is flume. Scoop is a one which is going to be used to get connected to the traditional database systems and get the data. Simply speaking, scoop is a tool which is going to connect to the traditional database, get the data. Flume is a one which is going to get the data from unstructured sources like Facebook, like Twitter. Those kind of data if you want to process, we are going to use a flume. Flume, scoop, HBase, Pig, Hive, MapReduce, HDFS, these are the main components which are going to be used to create a big data environment. And lastly, we have one more is there, that's Oozie. Oozie is a scheduling tool, right? Every day, my HDFS will get the data from some database, data warehouse database. To get the data from data warehouse database into HDFS, we want to run some scoop scripts. That's going to be scheduled with Oozie. And every day, some time is going to give by Twitter or Facebook to us, social media sites to us. At that time, we can contact to that particular Twitter, get the data from those Twitter logs or Facebook tweets and Facebook logs also. Then Flume is the one which is going to be scheduled to do that one.
Suresh, quick question.
Yes.
So, does Hive have some tables to store the data, or all the data storage is done only at HBase and Hive is just reporting there, like querying onto this HBase and reporting, bringing out the reports?
Right, exactly. The Hive is not going to maintain any data. It's going to connect to HBase and HDFS. See, when you create a Hive table also, in background, the Hive table is going to store in HDFS only.
Okay, it's going to store in HDFS. Okay.
Exactly. HDFS and HBase also, if you want to store, you can store.
Okay. Okay, thank you.
Yeah, I have a question.
Yeah, exactly. Yeah, you can ask.
Yeah, so whenever we have a data to import from source into Hadoop, so those are the only two that we need to use is Scooper or Flume, right?
Right.
We don't have any third-party tool.
Yeah, actually what you can see in few clients are using, in place of Scoop, they're also using ETL tools like Informatica, DataStage, Pentaho BI, Talent, these kind of ETL tools, okay, we also can see there. Simply speaking, those ETL tools also we can use in place of Scoop to connect to the traditional database and processing the data. For processing of that data, we can see that one as well.
Okay.
Even in my company also we are using in place of Scoop. Scoop is we are using from some database only. For other databases to connect, we are using Pentaho. Pentaho is one of the open source ETL tool. We are using that Pentaho ETL tool to connect to some other sources and processing the data. We will discuss, okay, around 40 hours of duration, 40 to 45 hours of duration, each and every component. Finally, after discussing of these all Scoop, Flume and HBase, everything, okay, what are the component we are having, we'll go for one POC also. One POC, okay, we are going to do on these entire systems, how we are going to perform and what kind of things. We will discuss that one. And if anyone want to do certification on Hadoop, okay, I'm also certified consultant in my company. I'll provide some certification related dumps and as well as materials. You can use those one. You can prepare for certification of Hadoop Cloud developer as well as Cloud administrator. What and we'll also discuss about the installation part and configuration, how can we do. And I'll also provide you plenty of materials. These are the class PPTs what I am showing you. Those I'll share you, and as well as assignments. What are the assignments we are having, and MapReduce programs. What are the MapReduce programs we are having? Those MapReduce programs also we provide, and certification related materials I'll share you guys. And along with that, I'll also share you some Unix scripts and Unix commands and Java materials also. And every day once the class completion, that class recording up also will be shared to you for future reference. And this is all about the way how I'm going to discuss this entire tool in 45 days or 45 hours or 45 to 50 hours of duration. Any other questions?
Yeah, I have one question. During the training, so the first thing that we need to do is the installation. So
I'm able to hear you.
Okay, the first thing that we need to do is to have the system. I mean the software in our system. So
Exactly.
And so, are you going to help us to install this?
Exactly.
This
Yes.
installation.
Yes. Once the basics is completed, introduction to Hadoop is completed. When I go for the configuration, that means cluster setup. When I'm discussing of that one, at the same time, I will also send you the software. I will show you in the class itself how to do setup. And once setup is completed, if you face any issue, for example, while raising the recording, you can do the setup in your machine also. It's not very big deal because these are open source software. It will take 10 to 15 minutes only to install. If you face any issue or something, I'll log into your machine from remotely. I'll install that one also.
Because personally, I would like to install it on Unix environment.
Yeah, you can. Any environment is okay. Unix or Linux or Windows or even Mac also okay. Mac operating system also we can use. Because there is no difference of installation, much difference of installation between one operating system to other operating system. Even Windows and Linux is almost same. For only Mac it will go to be a little bit different. So all the setups and installations I will show you in class, and I will send you the recording sessions of those, and I will share you those installation steps and PPTs to you. You can use those for your reference.
So what about system configuration?
Yeah.
What is the requirement for Hadoop to be installed on the system?
If you want to install Hadoop software in your personal machine, if you want to go for a single node setup, that means name node and data node same on same machine, you need at least 4 GB RAM should be there, and hard disk it will going to occupy around 8 GB something space. But RAM is very important here. 4 GB at least you need. If you see, for example, my machine having because I want to set up on multi-node cluster, I'm having around 32 GB is there. 8 GB is not working. I have right now 24 GB RAM. If you have high-end configuration like this machines, you can install multi-node also. If you have 4 GB RAM, for example, in your personal machines where you want to install Hadoop, 4 GB means you can go for single node. Even up to 8 GB also you can go for only single node only. If you want to go for more than that, if you have 12 GB or more than that, for example, more than that GB of RAM, you can go for multi-node setup of the cluster also.
Okay, yeah. Thank you. Thanks a lot, Suresh.